Okay, we're working on 6.7. It is the volume of cylinders, cones, and spheres. If we had a rectangular prism and I wanted its volume, one way to think of the volume is just find the area of the base. So if this was 4 inches and this was 3 inches, the area of the base is simply 4 times 3, which is 12 inches squared. And then we take that base and we raise it up through the height, let's say, which is 6, and that will tell us the volume of the rectangular prism. So we times this by 6 inches, and we get 72 inches cubed. So in general, if you have a three-dimensional figure and you can find the area of the base, multiply that area by the height, and it will give you the volume. So if we're dealing with a circular cylinder, and the radius of this is, say, 10 inches, and the height is 30 inches, the area of the base is pi times 10 squared. So what is the volume? Well, I just take that area and I raise it up through the length of the entire cylinder. So we times this by 30 inches, and we get 300 pi inches cubed. Okay. Now, what if we had a pyramid? So if I put a point directly in the middle of this, and I have this pyramid inside there, do you remember what the area or what the volume of that is? It's 1/3 base times height. So this pyramid that rests inside here is exactly 1/3 as big as the area of the entire figure, or the volume of the entire figure. Okay, so 1/3 base times height. Well, what if I had a cone? How big is that cone? It turns out it is exactly 1/3 base times height. So the area for a pyramid and the area of a cone are exactly the same. 1/3 base times height. So if you have a three-dimensional figure and you create a pyramid or a cone inside of it, that pyramid or cone is 1/3 of the entire volume. Okay, the only other thing is, what if I had a sphere with a known radius? What is the volume of the sphere? The volume of the sphere is 4/3 pi r cubed. And I don't really have an easy way for you to remember that one. 4/3 pi r cubed. So, all right, volume of a cylinder. This area is pi times 7.5 squared, and it is 38 feet high. So just multiply those together. That will give you your volume, and remember, volume is in cubic units. All right, volume of a sphere. So the diameter of the sphere is 15.2, so the radius is 7.6 millimeters. So the volume of the sphere is 4/3 pi times 7.6 cubed. All right. company makes wax candles in the shape of a solid sphere. Suppose each candle has a diameter of 15 centimeters, which means the radius is 7.5. The company has a total amount of 70,650 cubic centimeters of wax. How many candles can be made? So the volume of the sphere is 4/3 pi times 7.5 cubed. So 4/3 times 3.14 times 7.5 cubed is 1766.25 centimeters cubed. That's how much it takes to make one. So we're going to divide this by that number. So 70650 divided by 1766.25, and we get 40. So we can make 40 candles. What if the answer was 40.897? How many candles can we make? 40. We don't have enough to finish that 41st candle. All right. Volume of a cone. So this area down here has a radius of 4. So pi times 4 squared. Okay. And then we take this base and we times it by 12. And that gives us the volume of the cylinder. And then we times it by 1/3. So 1/3 times pi times 4 squared times 12. That will be your volume. Okay. All right. So these two shapes are similar. We know that the area of figure 1 is 150 square meters. The area of 2 is 260 square meters. The perimeter of figure 1 is 30. So what is the perimeter of figure 2? Okay. So these are proportional, right? So 150 over 216 is equivalent to 30 over x. So 150x equals 6480. Divide by 150, and I get 43.2. Oh, wait a minute. Uh-oh. That's not going to work. Let me show you. Okay. So look at this here. Everything on a two-dimensional shape that is listed in a single dimension is proportional to everything that is also listed in one dimension. But once you move on to 2 dimensions, then the rules get a little bit more complicated. Okay? So, the ratio of their corresponding sides is S. The ratio of their perimeter is also S, but the ratio of their areas is S squared. So, if I had a snowman and a smaller snowman drawn on my paper, if this radius was 4 and this radius was 6, and this radius was 8, and this radius was 2, how big would that radius be? 3. And how big would that radius be? 4. Because this snowman is exactly twice as big as that snowman. Now that's true for every one-dimensional measurement. So if I were to measure circumference, which is one-dimensional, then the circumferences would be proportional according to 2. But what about their areas? So if I have a circle with the radius of 8 and a circle with the radius of 4, is the big area going to be exactly 2 times the small area? No. Because area is given in inches squared. So it's going to be the square of the ratio. Let's not use 4 and 8. That's a little bit more confusing. So let's say this is 6 and this is 3. So the area of the big circle is pi times 6 squared, which is 36 pi. The area of the small circle is pi times 3 squared, which is 9 pi. Okay? So if I divide 36 by 9, I get 4. Why 4? Because this circle is twice as big as this circle, which means the area is going to be 2 squared times larger. Okay, so let's go back. So these are kind of tricky. All right, so the perimeter of figure 1 is 16, and the length of CD is 4. The perimeter of figure 2 is unknown, but EF is 7. So these are proportional because they're both listed in centimeters, one-dimensional measurements. So 16 over 4 is equal to x over 7. So that is 4 equals x over 7. Cross multiply, 28 equals x. So this is 28. Okay. What is my ratio here? Well, 16 over 28 simplifies down to 4 over 7. So my small shape is 4/7 as large as my big shape. 4/7 as large. So what about their areas? Their areas are going to be this much instead of 4 over 7. So 16 over 49. Okay. So if I start here and go in this direction, the areas are going to be 16 over 49. So I need to times this by 16 over 49. So 147 times 16 over 49, and I get 48. Ooh, that's tricky. I've never seen this problem before. Let's do another one. Nope, we don't want to do this one. This one's too easy. Okay, we'll do this one and then we'll decide. So, what is the ratio? Well, if I go from big to small, the ratio is 9 over 4. Okay? So, if I want to go in this direction, let's call this x. X times 9 over 4 is 16. So let's multiply this by 4 over 9. So 16 times 4 divided by 9 is going to give me 64 over 9. Oh, I'm going the wrong direction, huh? Thank you. Sorry. So if I'm going in this direction, it's 4 over 9. Thanks for pointing that out. So x times 4 over 9. So this is big and this is small. So this has to be less than 1. So x times 4 over 9 equals 16. So when I times this by 9 over 4, I get 36. So this is 36 centimeters. Okay? So if I want to go from here to here, I'm not going to multiply by 4 over 9. I'm going to multiply by 4 over 9 squared. So that's 16 over 81. 243 times 16 over 81 is 48. All right. Let's do one where they give us both areas. Okay, here we go. So, if I want to go from big to small, I get 216 meters squared over, oh, I did it backwards again, 150 meters squared over 216 meters squared. So 150 divided by 216 simplifies down to 25 over 36. But remember, this is my ratio squared. So 25 over 36 is my ratio squared. So to figure out what the ratio is, I take the square root and I get 5 over 6. So to go from here to here, I multiply by 5 over 6. And to go from here to here, I multiply by 5 over 6. So the perimeter of figure 2 is 36 times 5 over 6, which is 30. And then to go in this direction, it's going to be 6 over 5. So 5 times 6 over 5 is just 6. There you go. Do you need to see another one of those? No? You guys good? Okay. All right. Oop. So here we have some shapes with the cross sections. We're going to use those cross sections to look at the volume. So a slanted triangular prism, a slanted cylinder, and a right trapezoid are shown below. A plane parallel to the bases crosses the solids at the same level. Answer the questions. Figures are not drawn to scale. Okay. So you're going to find the area of each of these. Okay. And then B asks, if the heights of the solids are the same, which of these solids has the same volume as solid A? Okay. So if this area is equal to this area and their heights are exactly the same, then the volume is the same. In fact, if this area is equal to that area and the height is the same, then the volume is the same. So as long as all 4 of these have the same height, anytime one of the bases matches one of the other bases, then the volumes are going to be identical. If the bases have a different area, then they won't be equal with the same height. So every one of these shapes is base times height. So if the bases are equal and the heights are equal, then the volumes are going to be the same, even though they're totally different shapes. Okay, volume of a cylinder and a cone. So you're going to find this area, you'll find this area and then times it by the height. You'll find this area, times it by the height, and then divide it by 3. So if I take the big volume and divide it by the small volume, I should get 3. Or if you divide the other way, you should get 1/3. All right, that's it. Get to work.